Okay, let's look at a few more of the details associated with doing a best fit line on multivariable or two variable data. Share my screen out here again. Okay, so the goal, of course, is to find some sort of linear association between your data. Well, linear association is going to take the form y equals mx plus b. This is your old friend from high school math that just says the y value, or the thing on the vertical axis here, is explained by some linear function of the x value. Take the x value, I scale it by something, and I add something. The m is the slope. Hopefully that's review from good old high school algebra. So we interpret the slope as for every change that the x takes by 1 unit, the y goes up by the slope. So in the example of the Old Faithful data, if I were to change the wait time by 1 minute, so say from like 50 to 51 or 75 to 76 or whatever, then we would expect the eruption time to go up by the slope. So 0.08, okay, fine, 0.0756 minutes. The b is the y-intercept, and that's if x is 0, and I can see that here. If I put a 0 in for x, m times 0 is 0, my y turns out to be the y-intercept. Now, oftentimes the y-intercept doesn't really have any true meaning associated with the data. So in this case, if there was 0 wait time between eruptions, well, then you're still in the same eruption. And so this negative 1.87 doesn't really make any sense in context. What it does is it shifts the line up and down so that it actually matches the data well over here. So we can ask some questions, some really direct questions about this particular data set. Things like, if the predicted eruption time, or what is the predicted eruption time for a 70-minute wait time, or for a 100-minute wait time, or the other way around, what is a predicted wait time for a 3-minute eruption time? Well, we could do those from here. So if I go a 70-minute wait time, I can go to my plot and estimate that it's going to be a little over 3. But that's just an estimate. Or I could go to 100 minutes, which is going to be out here, and estimate that it's going to be maybe a little over 5. Again, that's just an estimate. Or I could go to a 3-minute eruption and come in here and say, well, it's maybe about a 65-minute wait time. Let's do a little bit better than that. So I'm here in the Google Sheet that has all of this same information, but let's actually go get some of these values. Now, of course, a spreadsheet software will do this for you. So if I go into, I've already got this kind of preset up, but I can do, for my slope, I can do equals slope of, and it just tells me data y comma data x. Well, my data y is in column B, so I'm just going to tell it to look at all of column B. My data x is in column A, so I'm going to tell it to look at all of those. And I got my slope. It's the same thing I got, but I've actually got more decimal places now. And I've got a way to reference it in the spreadsheet. So this is actually hugely advantageous. My intercept, well, let's try typing the way, look at that, the word intercept, good. My data y is in column B. My data x is in column A. Okay, my correlation coefficient. Well, if I don't know the command, I can always just start typing what I think the command could be. How about hey, there it is, correlation. My data y is in B, my data x is in A. You keep this in mind, it does ask for y first, then x. So make sure you don't get them backwards. So there's my correlation. And my r squared is my correlation squared. And there's the same value I had over here. So now we can start asking these questions. So question number 1, if wait time is 70, right, well, what do I get? Eruption time. Okay, well, I have a linear relationship between these guys. It's slope times wait time equals, or I'm sorry, slope times wait time plus my intercept should give me my eruption time. So I can take slope times my wait time, which I'm telling you is 70, plus my intercept, and I have a predicted eruption time. And I said it was going to be a little bit less than 4. Sure enough. Okay, the second question. If wait time is 100, eruption time is, well, let's see, that is slope times my wait time, which was 100, plus my intercept, and that gives me something a little bit less than 6, which is what I predicted from over here. Okay, what if my eruption time is 3? This is my predicted wait time. Now I've got to work this in reverse. So let's think very carefully about it. The eruption time is 3, and here's the equation. So I'm going to have to take my intercept and subtract it over, and then I'm going to have to divide by my slope. So I could do equals, okay, my eruption time minus my intercept. So I'm doing the algebra here. I'm subtracting over the intercept, divide by my slope. And I got something right around 65. Okay, and don't let the negative sign here fool you. It's this plus that I'm saying, hey, I'm going to undo that by doing a minus. This multiplication I'm going to undo by doing a division. Okay, now I can interpret all of these as well. So my slope is for every change in 1 minute of wait time, eruption time goes up by 0.076, rounding a little bit, minutes. Okay. The intercept, remember, this one doesn't always have a sensible interpretation, but what it means is if wait time is 0, then eruption duration or eruption time is negative 1.87 minutes. This is nonsense in context, because if the wait time was 0, that means the darn thing is still erupting, and you shouldn't be thinking about this. Furthermore, if the wait time is 0, you're a long ways away from the data, and you should think twice about using this model to predict that far away. Okay, correlation coefficient. A value of R equals 0.9 is quite strong. So there is a strong positive correlation between wait time and eruption time. Okay, and the R squared is 0.811, so let's see, sorry, I just lost my train of thought. Okay, I'm with it now. So we know that about 81% of the variation in eruption time is explained by wait time. Okay, so just by a couple of simple calculations, you actually get a lot of information about this particular 2-variable association. And furthermore, we answered all of these questions that we kind of thought would be sensible questions for this sort of linear regression. So what we're going to do now is give you a couple more data sets, and you're going to repeat the same process and do kind of similar things to it.